the functions, um, all of you emphasized on two things. I mean, you may not have been very conscious when you are presenting, but what you showed was that the shape of the function depends upon the parameters A, B, C, whatever there are certain constant terms in the function, and the values of the constants determine the position of the curve or the function, and secondly, the nature of the function. It can be upward sloping, it can be downward sloping. In case of the rectangular hyperbola, for instance, so it could be like this, or it could be like this. Even if it was U-shaped, it could be like this, or it could be like this, depending on the parameters. Or it could be something like this, right? Similarly, if you went to the log functions, it was either this or it was like this. And which of them? It depends on A, B, C, and so on. So what comes out from your discussion is that the importance of these functions, the parameters, what we called parameters of the function. They are crucial in doing two things: the shape of the function and to the location or position of the different curves. Now, when I'm talking about shape, I'm referring to two things. One is the slope, and the second is the curvature, whether it is convex or whether it is concave, right? Okay. Now, in economics, we have there are different examples of functions, but the most important function that we deal with is, particularly in microeconomics, is the demand function. Now, what is demand? Demand is the amount of a commodity that a person desires and wants to purchase. Now, if you just consider desire, right? Uh, would you be willing to keep up, let's say, a giant panda as a pet or a teddy bear as a pet? If I offer you a teddy bear, would you like to keep it as a live teddy bear? Would you like to keep it as a pet?
No, sir.
No, sir.
No. Why? Why not?
We can't keep it in a city. Like, it is not an animal that can be domesticated.
Then a giant panda,
Sir, I think it will be too giant, as the name suggests.
it's larger than you, but not it's not a real giant. And they're very lazy. They just sit all day and just eat. So you can keep it at your in your bedroom, and it won't even go out. So would you like to keep a panda?
Yes, sir. Why not?
But it's a lot of bamboo. Could you get
Yes.
that amount of bamboo?
No.
So
Yeah,
it's a lot of hustle to keep one.
yeah, it's a lot of hustle. I mean, although they are very, very lazy, I don't know whether you have seen a giant panda, a real giant panda. There's a red panda in Darjeeling Zoo, but I've seen giant pandas, and they do nothing. They just sit idle. I watch them for half an hour, and they have just moved one thing, and that is their mouth. So, but still, it's a hustle to keep them, as you say. You have to get a lot of food for them, and that means that you have to have. Uh, it's just not essential. It's not just needed that you desire to keep a panda. You also need something else, which is called
Money.
Purchasing
money.
power.
Yes. So it is just not desire which gives you demand. You also, this desire must be backed up with purchasing power. Okay. If you want to buy something and you have the money for to buy the commodity, then only it is demand in the economic sense. So we have desire plus we have the means to satisfy the desire. In that case only do we have demand. Now, demand depends upon many things, many factors, of which the most important is what we called sorry, what we called own price. So if I'm saying demand for X, the own price is Px. In the simplest form, we can write the demand function like this. Q is demand and it is a function of price. So in that case, what should come here? Ideally, Q should come here and Px should come here, right? The explanatory variable should come here and this is the dependent variable. But for whatever reason, the tradition is to write it like this. We always write demand over here and price over here. And the demand function is drawn like this. It can be like this, it can be like this, it can be negative. But the most important thing is the slope is negative. Okay. So this is the basic demand curve. Now, apart from own price, so own price is the first component. It also depends upon uh, the price of related good goods. I'm sorry, there'll be some. I won't be. Writing is very difficult for me, so I may make small mistakes when I'm writing anything. But now, when we're talking about related goods, we can have two types of related commodities. One are substitutes, and the other are complements. What are substitutes?
So,
If you want
The
to
goods which can be consumed in lieu of another.
alternate.
alternate goods, so like tea and
Okay,
coffee.
okay. So they are alternate. They satisfy the same demand. So either of them satisfy the same demand. And what are complements? As you have said, the example is tea and coffee. What are complements?
Goods which are
So both
consumed
goods
together.
Can be used
consumed together
together.
to satisfy
They have
our
to be
want.
consumed together.
Okay.
So
Which are
sugar and
consumed
Yeah.
tea.
together to satisfy a particular want.
Like tea and sugar or car and petrol.
So can I say that they are jointly used to satisfy the same demand?
Yes.
Yes, sir.
Okay. Yeah. And can you give me the best example?
So
Tea
sugar
and
and
sugar,
tea,
Car and
butter and
petrol.
bread, butter
bread
and
and
bread.
butter.
Okay, bread and butter. Someone said car and petrol. But if you look down,
So tea and sugar.
tea and
Pen and
sugar,
ink.
pen and ink, although I'm writing without any ink, but still, what is the best example?
Hardware
See, I
and
mean,
software.
yeah, hardware and software, that is true. Think of a very homely example. Look down. If you're sitting, look down.
Chair and table.
Yeah, that's also compliments. Look down on your, look at your body, the lower part of your body.
The shirt and pant.
No, you can have, let's say you can have a Rabindranath's Al Khalla, for instance. Or people can go about wearing just pants. When you were very young, you went about wearing only shirts. Okay. No, you may not
So
be
shoes and
using it
socks.
now.
Shoes and shoes.
Shoes and
Shoes and
socks.
socks.
Drop the socks.
Yes,
Sorry.
shoes. Only shoes.
Drop the drop the shoes, socks. Okay, there are two items, right and left.
And left pair.
A pair of
Left
Or
shoe.
socks.
if you
Right
talk
pair
about
of
shoes,
shoes and
if you
left
talk
pair of
about shoes,
Right shoe
right
and
shoe,
left
left.
shoe.
right and left.
Yeah. So if you have one, can you will it satisfy your demand?
No,
No,
sir.
sir.
If you just have
No,
the right shoe, I
no,
hope
no,
not.
no.
So,
Although
but
I saw a
demand for
person today.
one sock does not happen. Like if there's a demand for socks, it will be for both. So,
Yeah, but only in one case. One shoe will do. Do you know who this person is?
no, sir.
Have you read Treasure Island? None of
No,
you have
not
read
exactly.
Treasure Island. Not exactly.
Yes,
Okay.
sir, but I forgot the names.
So by Steven.
Who was Long John Silver? He was the villain.
Antagonist of the sea.
Yeah. What was his characteristic?
So he
How did
only
it?
had one leg. He had a limp.
Yeah. He had one leg and one wooden leg. So for Long John Silver, the right left shoe, they are not complements. He will require only one shoe. Okay. But anyway, for most of us, we require right and left shoe. Now, apart from prices, we also have income. Then we have taste and preferences. Can you think of a fifth factor? Think of demand for sweaters, pullovers.
So
Seasons,
seasons,
weather.
seasonality.
Culture.
culture in
হ্যাঁ,
wearing
বিভিন্ন দেশের
pullovers?
তো বিভিন্ন রকম কালচার হয় না? মানে আমাদের এখানে
হ্যাঁ,
যেটা অন্য জায়গায় তো সেটা নাও হতে পারে।
না, পুলোভারটা কখন পড়বে? নিশ্চয়ই কালচারের উপর ডিপেন্ড করে না।
না মানে আমাদের এখানে যেমন আপনার গরমের জামাটা বেশি, সেরকম অন্য জায়গায় যেখানে
সবসময়।
বা ওয়েদার যেটাই হোক কাল
So culture is one I accept. Although you can say that culture comes into tastes and preferences, season is also important. In summer, for instance, you will wear, your demand is for cotton, and in winter, you wear a different type of clothes. Okay, you wear sweaters, pullovers, so on. In the monsoon, the demand is for
Raincoat.
raincoats, umbrellas.
Umbrella.
Yeah. Now, umbrellas can be used in summer also, but certainly not in winter. So, seasons are important, tastes and preferences, which you can include as part of culture. They are also important factors. Now, we can write this as Q as a, let's say it's the demand is for a commodity X. So, PY, PC means it's a complement, PS means it's a substitute, M is income, S is seasons, T is tastes and preferences. We can also think of all other factors Z, but let's leave it out. So this is a, you have, it's not a single variable function. It's a multiple variable function. But if we hold all these variables constant, then it becomes a single variable function, which we are discussing now. Okay. We call this assumption ceteris paribus. Other things remaining same. So if we assume that all other factors remain same, we can say demand depends upon, it's the same as saying demand depends upon price of X ceteris paribus. That is, demand depends upon price of X, other things, that is all these things remaining constant. Now, if you have, if you write it in this way, we can plug in into this function, we can plug in different values of price. Let us say this is P1 and we are going to get X1. I can put in another value P2, which will give me X2. So these are movement along the demand curve. We call it a change in demand. So when is there a change in demand? When price rises or when price falls. Okay. Remember, we have the assumption CP, ceteris paribus. So the demand function that we have drawn over here, let us say it is D1. This D1 is based on a certain value of M1 and also PC, PS, season, T, and so on. Let's focus just on income. Okay. So when we are drawing this curve D1 and when we are allowing price to change, we are holding M to be constant at M1. Now suppose the income changes to M2 such that M1 is, sorry, M2 is greater than M1. So that means what is happening is price hasn't changed. It is still P1. So initially demand was X1. Now your purchasing power has gone up. So that means you can purchase more of the commodity, right? But you won't move like this because if you move like this, that means price has changed. Okay, so movements along the demand, as you're moving down along the demand curve, price is supposed to change. Price hasn't changed. What has happened is income only has changed. Price is still P1. So we have to be along this line. Okay. So that means your price must be kept constant. Now, what has happened is in this case, your demand curve you can where your income is not M1, it is M2. Okay. So is this clear? So this is called increase in demand or this is called contraction. Just 1 minute, please. So this is called contraction or extension of demand or movement along the demand curve. This is called increase in demand or decrease in demand or shift in the demand curve. So here, for instance, your income has gone up. You can also think of a case when income has gone down. So here you have, let us say, M0. Okay. So in that case, the shift will be inwards. There will be a decrease in demand. So keep in mind the functional implications that when you are, although you have, although the demand function is multiple, has multiple expected variables, uh, let's say these are related goods, income, days, season, and all other factors Z, we can keep all this constant, the ceteris paribus assumption, so that Q becomes a single variable problem, and we can draw this using in a just two-dimension space. So we get the demand curve, but as I've told you, this depends upon specific values of income, specific values of the related goods, specific tastes and preferences, season, everything is held constant. Okay, so if only the price changes, then you move along the demand curve. You move either up or you move down. But if any of these variables changes, then there will be a shift in the demand curve, either an inward shift to this point or an outward shift to this point. So the difference between these two should be kept in mind very carefully. Now you can see that the slope is negative. Okay, what does it mean? That if price goes up, demand will come down. On the other hand, if price goes down, demand will increase. This is the meaning of negative slope. Now the question is how much? Okay, I know that quantity is going to come down, but how much will demand change? So the answer to this is given by what we call elasticity of demand. So this is the what you say the percentage change in demand divided by the percentage change in price, and we write it as AP. Okay. So what is percentage change in demand? Del Q by Q into 100, and percentage change in price. So the 100 cancels out, and we can write this as now what is this? Del Q by del P?
Slope of the demand curve.
Slope of the demand curve.
So we can write this as in this way. Now because the slope is negative, we often put a minus over here to indicate that elasticity, value of elasticity is negative, and if you want to compare it for convenience, we should convert it into positive terms. That will make it very easy to compare. Now, I think most of you know what elasticity is, but I think at the same time, how many of you haven't had a course in economics at your HS level?
Sir, me, Upanita.
স্যার আমারও ছিল
So I had
11 12
economics.
I then
Sir hadn't. Upanita had.
Okay. So am I going a bit fast for you? So those who know what demand is, I think they can follow what I'm going.
Yes,
Yes,
But
sir.
sir.
I mean, if you think that I'm going fast, uh, please interrupt and say that you can't follow. So I'll shift to slower gears. Now, keep in mind this thing. Okay. Okay. Now I'll give you a hint. Elasticity ranges from infinity to 0. When will it be infinite? When is the elasticity equal to infinity?
Sir, when it is parallel to the x-axis.
So when it
Why?
is parallel to the y-axis.
When there is no change in price.
Parallel to the x-axis.
Why? I
When
mean, what is the
quantity
reason?
when quantity demanded changes infinitely in response
No,
to
just
change in
just
price.
Change in price is going to be
no.
0.
Look at wait. Just look at this, right?
So
So
when
we are
demand
saying,
is zero,
wait a minute. When
So when the slope is
I'm
0.
saying when is
When the
t
slope
equal
is
to
zero.
infinity, right? Just think of it as a number. So what it is basically theta by slope when theta is
Yeah.
equal to p by q. So when is it infinite? Slope has to be 0. So a line has a function has a slope 0. Okay. What does it look like?
So it is parallel to y-axis or the price axis.
Parallel to the x-axis.
Parallel to the
It is
quantity demanded axis.
parallel to the y-axis. Okay.
The price y-axis.
Okay. Again, what is slope? Wait a minute. Let me go into the derivation. It was the change in demand by change in price. Right. So E by Q goes into the top. Right. So this has to be equal to 0. Can del Q be 0? In that case, this will become infinite, right?
yes.
Del P has to be 0. See, in this case, price is changing. Del P is positive. But what is del Q? It is 0. So this is not the case. Del P 0 means now price is the same, but del Q is positive. So if
So
the
here
demand,
the elasticity is zero
no,
in the
this, yeah,
oh no no no.
this one, but
Yes,
I'll
yes,
come to this.
yes.
Let's take
Okay.
it step by step.
Okay.
Okay, so this is a case when elasticity is infinite. Okay, now let's go to the other extreme. It's always good if we move from one extreme to another. Then the middle ones will get solved by itself. Okay, and let us say elasticity is equal to 0. So that means, in fact, let's take this part, right? It will be easier. See, quantity and price is always positive. Okay, so P by Q is always positive. When can this be 0? Don't look at this, look at the first equation. So this is positive, this is P, this is also positive. When will this be 0?
When the when the change in quantity is 0.
When the
Yeah, so
quantity doesn't change.
the
When
numerator
the
must be,
quantity doesn't change.
yeah, so the numerator must be 0, right? Del Q must be equal to 0, which is this case, right? So this is a case when price elasticity is equal to 0. The two extremes. So if you can remember one, you can always remember the second one. Now, in between, we can have uh, elasticities can be, see, if it starts from 0, it will be, let us say, zero point 0.2, zero point 0.4, 0.79, and so on. Then we assume it's equal to 1. And then 1.1, 2, 7.4, 99.2, and so on. So here elasticity is lies between 0 and 1. Here elasticity is equal to 1, and this is a case, right? Okay, let us say this is case A, B, and C. Again, we'll look at these. See, in this case, case A, what we are basically seeing is elasticity is very low. So that means price changes, but when price changes, demand will obviously change. Demand falls, right? Okay. But the fall is very low. On the other hand, here also price changes, demand falls. In this case, the fall in demand is very high. Just let's think of a curve, and this is the change in price, and this is the change in demand. Okay. Now, let us think of another demand curve. See, the two, in both the cases, the change in price is the same. Okay. In the first case, del Q1 is the change in demand, right? Now, suppose this demand curve is more elastic, right? So, the fall in demand, the change in demand must be very high. It must be higher than del Q2, must be greater than del Q1, right? See, del P is, we have deliberately assumed del P to be same, right? So that means the del Q must be very large. So this will be the curve, right? So if you look at the two curves, what is the difference visually? One is the position, forget about it. But visually, what is different about the two curves?
The second one is flatter
Sir,
than the first
flatter.
one.
One steeper.
Yeah, right. This is flatter and this is steeper, right? So if your elasticity is high, in general, you'll have a flatter
Flatter
demand
curve.
curve. On the other hand, if elasticity is low, you'll have a steeper demand curve. Again, it's in general because remember, P and Q is also comes into the picture. And I can show you a demand curve where the slope is always constant, but elasticity changes. Okay. Okay. So that means when we are talking about these demand curves, sorry, see what was the zero demand curve? Price elasticity zero, this one. So it will be very steep curves like these. These are elasticity between what we call, these are inelastic demand curves. Sorry. On the other hand, this was price elasticity equal to infinity. See, these are much flatter. These are what we call highly elastic or simply elastic demand curves. Okay. So logically, I mean, if you just think about it logically, once you have defined the two extremes, this is EP equal to price elasticity is equal to 0, and this is price elasticity equal to infinity. You can find out A and C. Okay. So this is what we called elastic demand curves. They will be flat, relatively flat. These are inelastic demand curves, which will be relatively steep. Now, what do you think will be the slope of the case B? Elasticity equal to 1. So what I'm trying to show is, if you know the two extremes, then just by inducing, applying the same logic, you can also derive the interior cases. You just need to know the boundaries properly. So elasticity is equal to 1, what we call unitary elastic demand curve. What is the slope like? On one hand, we had seen very flat. On the other extreme, below 1, very
This will be,
steep.
yeah.
Sorry?
No, sir, continue. I was just saying this will be a straight line. Yes.
Okay. Well, it might appear that it looks a straight line will be elasticity is equal to 1. But actually, what happens is, if you draw a straight line and, right, you take any point, elasticity for a straight line is given by BC by AB. So if you take a point on the demand curve, linear demand curve, and you call it B, the lowest segment by upper segment. The ratio of these two segments gives the elasticity. So they will be equal to 1 only if AB is equal to BC. Right? I will prove this later on. In fact, if any of you can prove it in the next class, but it will be great. But the important thing is that if you know that for a straight line, this is the elasticity, then you can see a linear demand function. It is equal to, elasticity is equal to 1 only at one point, when B is the midpoint. If we take a point close to A, let us say B1, right? This will be the lower segment is above, so it will be +1. On the other hand, if we take a point like B2, this will be less than 1. So this will be elastic. This is the elastic zone. This is the inelastic zone. And in the midpoint, you have elasticity equal to 1. Okay. So the straight line, surprisingly, is not the case when of a unitary elastic demand curve. In fact, some of you during the today's presentations, before I had presented, some of you, one of you have already discussed the demand curve, which will always be unitary elastic at all
Is it
points.
A rectangular
rectangular
hyperbola.
hyperbola?
So could you please explain the last part of elasticity where you have written B1 and B2, elastic and inelastic?
Okay. So what I've said is that if the demand curve is a straight line, then elasticity is defined as lower segment by upper segment, lower by upper. So we take any point. This is the lower segment. This will go into the numerator. This is the upper segment, which will come into the denominator, right? So BC will is the lower segment numerator. AB is the denominator, right? Now, if B is the midpoint, then BC and AB are equal, right? So price elasticity will be 1. But if B1, suppose we take a point close to A, then B1C is much larger than A1's AB1. See, this area is much larger than this area, right?
Yes, sir. Yes, sir.
So this is the denominator, this is the numerator.
Yes, sir. So
It's
it has to
highly
be
elastic. And if you take a point like this, it's the opposite, right?
yes, sir. Yes, sir.
Now, a rectangular hyperbola gives the case when price elasticity is equal to 1. Can you tell me what are the two most important properties of the rectangular hyperbola?
The
It is
curve does not
parallel to.
touch the x or the y axis.
Okay. We say that it
So it
is
will be the constant area.
In
right.
nature.
It is asymptotic to both axes. This is something that we will come to later when we discuss cost curves. The second property is that the area of a rectangle is constant. So that means if we take any price, this is price and this is quantity, P1, Q1. We take another price quantity, so any rectangle is constant. Whichever rectangle we take is constant. So this is a very important property of unitary elasticity. Okay, so I'll end at this point. I'm sorry to have taken a bit more of your time, but I couldn't present midway. Thank you for your patience. So any questions on what we have discussed so far? And those who don't know economics, I mean, please feel free. If you have any problem, discuss. Just say. And if you are very, very shy, see, first of all, no one can see on internet. And if you're that shy, just contact me, just mail me. Okay, so no questions. So I'll stop presenting. Acha. When is my next class? Wednesday, right?
Yes, sir.
Okay. So just a minute, I'll tell you.
Is the class over? I'm not sure.
I don't think so.
He said to wait, but now he has left.
Oh, okay. Thanks.
Are you people leaving or what? Like, are you staying? Like, sir is not here.
Actually, it felt like he was going to say something or give some information, so I'm not sure.
It is
Let's all
still
leave.
recorded.
Yeah. I thought that too, but he suddenly left the meeting and like I don't know.